Okay guys, Matt here, artificial intelligence. Looked through the subject list on the channel, noticed that artificial intelligence was missing. With most of the subjects actually I've talked about, I'm no expert. And in fact, I'm not really an expert on this, but I do have some background in AI. So I have an unfinished PhD from many years ago in artificial intelligence. It was in an area called case-based reasoning. And CBR is a kind of, well, there's a mixture. You can use multiple sort of techniques with it, but the overarching idea of case-based reasoning is to get machines to recognize similar situations or similar problems or cases that they've encountered in the past, and to sort of redeploy solutions that have been used on similar problems, similar in sort of in inverted commas there, because how do we define similar? So with case-based reasoning, I mean, I suppose the simplest example might be, imagine your case only has two dimensions, right, x and y, and they're both sort of continuous values, mathematical values. So, it could be height and weight, right? So let's say that particular combinations of height and weight tend towards certain conditions, right? I don't know, maybe diabetes is associated with short, heavy people. I don't know, just an example, just think of some sort of simple example. So you can imagine plotting all of those particular cases on a 2D graph, right? This is where you can imagine things like clusters forming. And so let's say there's a particular cluster and a sort of concentration of dots in a certain area. And if you look at the kind of, I suppose you'd call it the output variable, is whether they have some condition or not, right? Diabetes is probably a really bad example, but just condition X, yeah. And let's say that that this particular or proximity to this particular area gives you an increased likelihood of having condition X, right? So that's how you compute similarity in that very, very simple space, right? So you've got two coordinates, and you can use Pythagoras theorem to compute the distance between points within this space. So this is called Euclidean distancing. Right, and you can do this to any number of dimensions. So you could have a case with, say, 10 attributes. You could have a mixture of continuous variables. You could have categorical variables. So you could have sort of age, height, nationality, and so on and so forth. And again, you can position these within what's now called sort of n-dimensional space. Right, so you're still doing Euclidean geometry, but just to extra dimensions. So yeah, that's how that's one of the features of case-based reasoning, is to kind of use mathematics to compute the similarity between cases. And then those cases would have some sort of output variable, or it might be a problem that's been encountered and it has a particular solution, so you can try to redeploy those solutions. So a way of thinking about this is, imagine you're a carpenter, but you've only ever made tables, right? And then someone comes to you and says, "Oh, I want a chair." Now, the plucky carpenter will say, "Well, I've never made a chair, but give me some idea of what this chair is, and I'll try and make it for you based on my prior knowledge." So, once he hears this description, he might think, well, actually, that chair is just kind of like a table it's a smaller table with a kind of backing thing, put on it. So maybe sort of two of the legs could be sort of twice the length of the others, and so you can then put a backing on it. And so, humans are very, very good at adapting prior knowledge to new situations, but computers aren't. And so CBR, or case-based reasoning, was kind of a philosophical approach to AI that sort of said, look, this is what we kind of need to get computers to do, is to be able to have memories, and to be able to sort of deploy those memories on future problem situations. I mean, you could use neural networks with this stuff as part of a kind of a hybrid approach. And one of the key things with it was actually maintaining the knowledge base that you have. So obviously new cases get added into the history. Your predictive capabilities can be tuned based on performance. You can change weightings associated with particular categories. You might, for example, height might be a more significant attribute than weight for particular outcomes, and so on and so forth. So, but the upshot of all of this with AI is that, the whole idea was to try to build software that does stuff a bit like the human mind. Okay, and I suppose it would follow naturally that things like neural networks, which you can kind of simulate in software, would be the approach to that, because that's what goes on in the human brain, right? So you can call these things, what would you call them, sort of classifiers, right? So it's kind of information goes in, it's associated with particular outcomes or ideas or classifications, things like that. And so you can think about sort of training neural networks to identify cats. And like a child, if a child points at a dog and says cat, you say, no, that's not a cat. And you're like, why, mummy? Well, because cats are a bit smaller, they don't bark, so, and these are the sorts of things that you can simulate this mathematically with neural networks. So you sort of tweak, you can kind of train neural networks, so you can give them additional sort of inputs, and you can do a bit of kind of sort of human guided learning with these systems. So what's all the furore about AI lately with like these large language models, the idea of AGI just sort of being around the corner? AGI is sort of artificial general intelligence. So we've got AI is all over the place, right? So there's no point in panicking about AI getting here, because we have AI and we've had it for decades, right? So there's AI in your phone, sort of little decisions being made here and there and everywhere, right? Sort of conditional decisions. If you swipe here, then put those images there. I mean, there's a certain amount of intelligence, or not cognition, but kind of mechanical intelligence underpinning all software, right? So AI is kind of already here, but kind of machine learning and things like that, and predictive analytics, that's a sort of step up, right? And again, but we've had that for some time. We've had modeling and we've had predictive analytics for some time. Large language models, probably the biggest step forward in kind of human technology for ages, right? Because we have literally now built a system that we can talk to. It passes the Turing test. The Turing test being this test to see whether you could distinguish software from a real human being. And these days LLMs they smash that test into the long grasses, really, as far as I'm concerned. It's freakishly amazing. I mean, obviously you get hallucinations and it makes mistakes, and I've got to really, really emphasize here that there is no understanding within these large language models, right? So they turn the words into numbers, right? And then it's just sort of statistical kind of model then that just computes the most likely sort of string of words, the following of a given word, and so on and so forth. So there's more to it than that. I'm no expert. Like I say, I'm quite generalist in most areas, but I do have some background in AI, so I've got a bit of a feel for what's going on in there. But these things, I don't think they're ever going to have phenomenal consciousness. But I've been having some doubts about this lately, and I can't quite put my finger on exactly why. But it just seems that Mike Levin's work is pointing to this idea that mind is everywhere. So even these most basic systems, say basic, it's probably a misnomer as well, isn't it? Sort of maybe less advanced is the best way to say it. Sort of forms of cognition and mind everywhere. And if that's the case, then why shouldn't kind of assemblies of stuff that we've manufactured possess the same features? But phenomenal consciousness is a slightly different thing. The actual qualia, because then you've got the problem of the sort of homunculus, that being that's observing all of the kind of the information processing and so on and so forth. I mean, look, I'm going to go all the way back to when I was like 10 or 11. I had a ZX Spectrum. We used to have to type in computer games. So the software was like the magazine. I get really excited going out to Totten Computer Store and buy these magazines, right, and leg it home, and then spend 3 hours typing these games into right? And I mean, you could then save the game onto a tape cassette, so you didn't have to keep retyping it. You could kind of load the game. But that's how I learned programming, and I was like fascinated by these little entities moving around the screen. So I thought, right, I want to make my own game. So I did that, and my games would have monsters in them. So you'd have like a little sort of 2D overhead view of like a little adventure guy that could pick up swords and shields and enhance his strength and defense, respectively. And if you go off the left side of the screen, that would bring up a new screen. So you'd have some sort of statement like, if X is 0, then check what screen we're on. And because obviously I'd have I think like a 5x5 grid of screens. So if you go left, you could just sort of -4 or something, I think, and that would give you the screen reference to go to. So you'd load that screen reference and then carry on. But the interesting thing was about how to get the monsters moving around and how to make them respond to me, right, or the player. And so some of them, I'd have them moving at the same speed as me. So every tick, or the same speed as me if I was moving maximum speed. So every tick of the game, they'd move 1 block, right? And some of them I'd move at half speed or 3/4 speed and stuff to make them all sort of slightly, have slightly different threat levels against me. But then I thought, actually, let's make some of them like stupid, so they just move randomly, right? So you've got fast random ones and slow clever ones, right? And the clever ones, basically, they check their position against you every click. And if X is greater than P, then make P equals P plus 1. And if Y is greater than Q, then let Q equal Q plus 1, right? So they'd, if you're opposite ends of a square, they diagonally kind of approach you click by click, right? So I thought that was quite cool. And then you'd sort of have, and then you'd have some of them that move randomly half the time and some of them that move towards you half the time, right? But then there was what I thought I could make it more interesting. I sort of put obstacles in the way. And, so if certain monsters encountered a red brick, they couldn't go through it, but they could go through blue bricks, right? And then I thought, well, if they're against a brick, then they're just going to keep trying to move down, but the brick blocks them, so they'll just stop there, right? So I thought, no, I need to program in a conditional that says that if a tick has gone by and you're still south of them and they haven't moved, then that confirms that they're next to a brick. And I said, if that's the case, then basically move left or right according to which direction you were in on the y-axis, right? So if you were to the east, they'd move east, and if you were to the west, they'd move west. And I thought this, I thought actually this is silly because they can't see me through that wall. So how would they know which way to go, east or west, right? And that got me thinking about having a line of sight. And that's where it got really complicated, and I think I, got lost with some of the mathematics. But I thought a range of sight was quite easy. So what you could do is the creature would only notice you if you were within a range of, say, 4 squares from a central location, right? And then, I had to do some kind of like, I did fairly ham-fisted mathematics to get a circle-like radius. Because, I wasn't dealing with very small pixels here. I was dealing with blocks. These were UDGs, kind of like 8x8 characters that you sort of had to define using binary. So, I got really, really interested in the idea of, what is it that, what is a creature? And then I used to get into these games, building my own kind of environments where I suppose it was like an early form of A life. I was about 11 or 12 doing this stuff. I was an only child until my little brother Richard was born when I was like 11 or 12. So I spent hours in my bedroom doing all this coding. Years before, he spent hours watching ants. So, I even tried to simulate ants once and gave up on that in the end as well. I tried to write a chess program. Quickly got lost after realizing that I needed like a general problem solver rather than a conditional problem solver. I was building kind of nested if statements and go-tos and all kinds of stuff. I managed to get to move 2 and then realized this is impossible. I think my maths was weaker than it should have been. I think my logic was good. But yeah, so I used to build these environments where plants would grow over a period of time, different rates, and animals wander around and fight among themselves. Now, this is where I didn't go to that next level, which is where, I never kind of had them reproduce and mate and things like that, right? Which is where there was this guy called Steve Grand, I think he is. Steve Grand, he wrote software called Creatures. And that would have creatures reproduce and mutate, right? And so, it was kind of almost like an evolution simulator. And I never really I only discovered this years later because he wrote this interesting book called, what was it, Life and How to Make It. And he talked about persisting forms. It was quite philosophical in places. And it reminds me of some of, not the material or the content as such, but some of the way that Mike Levin kind of approaches things. kind of like a sort of mixture of sort of like a philosophical engineer or something somehow. But although Steve Ground's approach was kind of like top down, he said, look, just stop philosophizing about the nature of reasoning and thinking and stuff. He said, let's just build an entity that walks about and can see stuff. And, you know, and he started building, I think he built like this kind of robot orangutan, Lucy, I think her name was. And, you know, this is ages ago. I mean, this is absolutely ages ago. So all this kind of, you know, hand waving about AI and stuff lately is nothing to be alarmed about, because AI has been being developed for ages. But it is the case, it is true that these large language models are a massive step forward, because they're basically going to take a lot of jobs away from human beings. And I think this was 6 months ago. I think BT laid off thousands of staff and replaced them with large language models. The legal profession could go. The image generation software can probably replace modeling. Eventually, when graphics get so good, will we need human actors? If we can actually generate better looking, better actors, right? And this is the thing with AGI, right? AGI is really, that's when things go freaking crazy, because we end up with thinking architectures that can solve problems that we can't even conceive. Right, so they'll start generating new conceptual insights into the knowledge and understanding that we already have. They'll suggest new branches of science, new branches of medicine, new branches of research. But the thing is, they will have to live collaboratively with us for some time. They depend on us to keep the power going and the switch and so on and so forth. So we're not going to end up in Skynet in the next 10 years, okay? I don't think we'll ever end up in Skynet. I think we will live in harmony with them, and by the time that there's any chance that AGI will start getting pissed off with us and thinking actually humans are a pain in the arse and start fucking around with, what was it, Asimov's second or third law and all this kind of stuff, by the time we get there, I think biology will already be profoundly sort of transhumanistically integrated with silica anyway. So it's it's not like the robots are going to separate off from us, because they're an extension of us. They are us, right? And I think this is kind of one of the things that Levin's sort of talking about, that we shouldn't be too hasty to draw distinctions between classes of entities. But anyway, so AI. I mean, so look. I mean, I think Levin's argument about a mechanistic. Or sort of mechanistic devices never being able to produce consciousness, I think it's still pretty compelling. But then at the same time, these materials are only made out of the same stuff that the rest of man is made out. We're made out of bits of mal, and we've been configured in such ways to be able to give rise to phenomenal consciousness. So I just don't know about that area anymore. I'm really kind of quirkily bumbling around in the darkness in that area at the moment. I don't know, is there a panpsychist sort of leaning within this somehow? I don't know. One other thing, actually, I bit of a sort of blowing my own trumpet. It's a bit silly, really, but I worked for this company many moons ago. It was an Indian business intelligence company called Acrotrend, and they're pretty cool, actually. Some really amazing Indian software developers and stuff that I work with, and business analysts, and they were looking into AI sort of, about 10, 15 years ago. And I said, look, I know about this. I have this tendency to sort of stick my head above the parapet sometimes, and quite often have it blown off, right? But hey, fortune favors the brave. But I said, look, I know about case-based reasoning and Euclidean distancing, and I reckon I can come up with a model that can compete with Mark Lawrenson, who was a football pundit at the time. And he used to offer up these predictions for match results every single week, right? All the Premiership matches, Man U, Liverpool, Everton, Chelsea, all these guys. And I think he was generally running at about sort of 37% accuracy, right? So what he was predicting was home win, draw, or away win, right? I think he was predicting the scores as well, right? But I thought I'd start with something simple: home win, away win, or draw. And I used case-based reasoning, and I came up with a model that I think it totally outperformed Mark Lawrenson, and he was an expert, right? So he had all the narrative, the cultural history, the training. He played football. I think he was a manager. He was a pundit. he knew football. He was football. But my model on a spreadsheet defeated him. Right. So at one point, my accuracy was just ridiculous. It got up to about sort of 60%. I think the overall for the 20 matches that I ran it for, because it was quite a lot of manual effort. I mean, I didn't have it in SQL. It was all spreadsheet based because I couldn't explain to the developers how I was doing it. They just didn't get it. So basically I'll give you an outline. If I can remember exactly how I did this, I'll be amazed, but I can give you an overarching view. So the way I approached it was I didn't care about the names of the teams. All I cared about was the performance dynamics of the teams in those matches. And so I built up a history of these performance dynamics. So what position were the teams in when they played? What was their position in terms of goals scored? What was their position in terms of goals conceded, right? In the history. So for those kinds of matches against teams that were characterized similarly based on there was a certain amount of recency, but there was also their actual overarching position in the cumulative sort of league table, right? And so each team would be characterized as a home team with a particular performance in terms of goals scored, a particular performance in terms of goals conceded, and a particular position in the league, I think. And the away team would be described accordingly. And so the result would be based on the proximity of prior matches to that new match, based on a kind of n-dimensional mathematization of those attributes that I just mentioned, right? And it frickin' worked. So it wasn't anything to do with the fact that it was Man United versus Chelsea. The only thing that it had to do with was the performance of those teams, right? And based on those performance metrics that I selected, which was goals scored, goals conceded, and I think league position at the time of the match, right? So I out predicted Mark Lawrenson. I mean, it was hardly a crystal ball. I mean, I think eventually my prediction accuracy trailed off to sort of like about 43% or something, but that's still preferable to the random chance, which is 33, because there are 3 possible outcomes for each match. So random would give you 33%. Right. So anything above that is a win. But like I say, I defeated Mark Lawrenson, and that's my little claim to fame in terms of artificial intelligence. But it was hardly a crystal ball. Not enough to win the pools or make me famous. Cheers, guys. See you later. Bye.